Hello everyone. Today we'll be going over 2.6, proving geometric relationships. Alright, for theorems. Theorem 2.3, right angles congruence theorem. All right angles are congruent. So for example, let's say this is angle A right here. And let's say this is angle B. And if they're both right, if they both have right angles, angle A is congruent to angle B. Theorem 2.4, congruent supplements theorem. If two angles are supplementary to the same angle or to the congruent angles, then they're congruent. If angle 1 and angle 2 are supplementary and angle 3 and angle 2 are supplementary, then angle 1 is congruent to angle 3. Theorem 2.5, congruent, for theorem 2.4, it makes sense because if you say some two angles are supplementary to each other, they add up to 180 degrees. And let's say angle 1 is 50 degrees. And that makes angle 2 130 degrees because angle 1 and angle 2 are supplementary. But it also says angle 3 and angle 2 are also supplementary. And you know that angle 2 is 130. So that makes angle 3 50 degrees. So you can say that angle 1 is essentially equal to angle 3, which is shown right here. For theorem 2.5, congruent complements theorem. If two angles are complementary to the same angle or two congruent angles, then they're congruent. If angle 4 and angle 5 are complementary, and angle 6 and angle 5 are complementary, angle 4 is congruent to angle 6. All right, that makes sense too, right? Because let's say angle 5 is 60 degrees. And you know that angle 4 and angle 5 are complementary, which means they add up to 90 degrees together. That makes the angle 4 30 degrees. It also says angle 6 and angle 5 are complementary. So that means angle 5 plus angle 6 is equal to 9 degrees, which makes angle 6 30 degrees as well. So that means angle 4 is congruent to angle 6. Another theorem, postulate 2.8. Linear pair postulate. If two angles form a linear pair, then they are supplementary. Angle 1 and angle 1 form a linear pair, so angle 1 and angle 2 are supplementary, and measure of angle 1 plus measure of angle 2 equals 180 degrees. So you know that a line, basically a line is 180 degrees. And essentially this angle plus this angle is 180 degrees. Pretty simple. Theorem 2.6, vertical angles congruence theorem. Vertical angles are congruent. For example, angle 1 is congruent to angle 3, angle 2 is congruent to angle 4. This basically just means that vertical angles are congruent, which means that if angle 2 is 30 degrees, that makes angle 4 30 degrees. And if angle 1 is 20 degrees, let's say, angle 3 is 20 degrees. Next slide. All right, so for practice, in exercise 7 through 10, use a diagram and the given angle measure to find the other three measures. All right, so for number 7, it is given that measure of angle 1 is equal to 143 degrees. So according to vertical angles are congruent theorem, you know that angle 3, measure of angle 3 is also 143 degrees. So measure of angle 3 is 143 degrees, just like measure of angle 1. And according to the supplementary theorem, you know that a measure of angle 4 plus measure of angle 3 is 180 degrees. So measure of angle 4 is just basically equal to 37 degrees because they have to add up to 180 degrees. And if measure of angle 4 is 37, you know that angle of measure of angle 2 is also 37 degrees because the vertical angles are congruent. So that's it for number 7. Let's do number 9. So it is given that measure of angle 2 is 34 degrees this time. So again, according to the vertical angles or congruent theorem, angle 4 is 34 degrees because it is vertical to angle of measure 2. And once again, according to supplementary theorem, if it's on a linear line together, it has to add up to 180 degrees together. In this case, measure of angle 4 plus measure of angle 1 has to be equal 180 degrees. And you know that the measure of angle 4 is 34 degrees. So you just subtract 34 on both sides and get, for measure of angle 1, you get 146 degrees. For measure of angle 3, it is the same because of vertical angles are congruent theorem. All right, I'm going to move on to exercise 11 through 14. Find the values of x and y. All right, for number 11, you know that 8x plus 7 is equal to 9x minus 4 because of vertical angles are congruent theorem. So basically, you just set them equal to each other. You have to move the x's by one side, so I'll subtract 8x on both sides and get 7 is equal to x minus 4. And if you add 4 on both sides, you get 11 equals x. All right, so we solve for x. Now we solve for the y. Again, 5y is equal to 7y minus x 34 because of vertical angles are congruent theorem. So this time I'm going to add 34 on both sides this time. So 34 plus 5y is equal to 7y. And then I'm going to subtract 5y on both sides, which would give me 34 is equal to 2y. And y ends up being 17. So for number 11, 11 equals x. And y equals 17. In different color, I'll do number 14. All right, let's see. So just like number 11, but with different values, you know that 2 times 5x minus 5 is equal to 6x plus 50 because of vertical angles are congruent theorem. So basically, 2 times 5x minus 5 is equal to 6x plus 50. This would get me 10x minus 25. Oh, sorry. 10x minus 10 if I distribute it. So I have to put get the x's on one side. So I'm going to subtract 6x on both sides, which give me 4x minus 10 is equal to 50. And then if I add 10 to the right side, or for both sides, I get 4x is equal to 60, and x would end up being 15. If I solve for, so okay, x equals 15 for this. So 14, x equals 15. If you want to solve for y, you once again set 5y plus 5 is equal to 7y minus 9. So 5 equals to 2y minus 9. 14 is equal to 2y, y equals 7. If you want to check if it's right, you can plug it in. So if you plug in 7 for y, you get 49 minus 9, which is 40 for this side. And then if you plug in 7 for 5, you get 35 plus 5, which is 40 again. So it does work out. All right, pretty simple. More practice. In exercise 15 and 16, describe and correct the error in using the diagram to find the value of x. All right, so in this case, this person got number 15 wrong because, as you know, you can either add these two angles together and get 180 degrees, or you can either set the vertical angles to equal to each other and find out x. If you do this right, you're supposed to get 13x plus 45 is equal to 19x plus 3. So 45 is equal to 6x plus 3. So 48 is equal to 6x. So an x equals 8, not 4.125. If you want to check, you can plug in 8 for x. So if you plug in 8 for right here and here, you get 48 plus 2, which is 50 right here, and then 8 times 12 is 96. Oh my god, 6 times 8 is 54, plus 2 is 56. And for this, if you multiply 12 by 8, you get 96 minus 40 is 56 as well. So 8 does work out. And then for last one, number 18, proof. Copy and complete the 2-column proof, then write a flowchart. I'm not really gonna do a flowchart because that takes a lot of effort. I'll just simply explain. So for given, you know that angle ABD is right angle. So this here, right, is right angle. And it also says angle CBE is also 90 degrees. All right. So according to the right angle theorem, whatever that is, you know that angle ABD is congruent to angle CBE. And this problem wants you to prove that angle ABC, which is right here, is congruent to angle DBE. All right. From what we learned, you know that angle CBD plus angle ABC is equal to 90 degrees because it says angle ABD is right angle, and the angles that make up angle ABD is basically angle CBD and angle ABC. And they are complementary to each other. And for angle CBE, the angles that make up angle CBE are angle DBE plus angle CBD. And they also add up to 90 degrees because you're given that angle CBE is in a right triangle. From what you see right here, you can basically set angle CBD plus angle ABC is equal to angle DBE plus angle CBD, because they're basically both 90 degrees, and 90 degrees are equal to each other. As you see right here, you see that angle CBD are on both sides, so you can basically subtract and get them away. So you're left with angle ABC is equal to angle DBE. And basically, if they're equal to each other, they're also congruent to each other. I think that's it. So thank you for watching. Peace.